Hello students, my name is Professor Swati Rajput of SIRT College EC Department. Today, this is my first lecture of the series Analog and Digital Communication, and this subject is present in CSIT and EC Department. Today, we are going to study about signals and types of signals. So, let us start. So first of all, let us deal with what is signal. Signal is a function that conveys some information. Do you know what is information? Information is anything that is transmitted from sender to receiver. And how is this possible? Through communication. So, a signal is a function that conveys that information about a phenomena, and it is of various types such as continuous time, discrete time, analog, digital, deterministic, random signals. These are of many types. A signal can be defined as a function of one or more independent variable which conveys a information. Okay, so we will study about classification of signals. Signals can be classified mainly as CT and DT. Here it is mentioned as continuous time signal and discrete time signal. Continuous time signal is also called as CT signals and discrete time signal is also called as DT signals. So let us see first what is continuous time signal. A continuous signal may be defined as a mathematically continuous function. This function is defined continuously in the time domain. Here we can see that this waveform is going continuously, okay, as it is determined as continuous function, okay. The continuous time signal, the independent variable is time t, and a continuous time signal is represented as x of t, okay. Then what is a discrete time signal? A discrete time signal is defined only at a certain time instant. Here in this we can see that how it is not continuous. It is at different time instants. For a discrete time signal, the amplitude between two time instant is just not defined. For a discrete time signal, the independent variable is time n. A discrete time signal is represented by x of n as it is mentioned over here. Okay. Then classification of CT and DT signals. Now signals, as I told you, is classified as CT and DT. Now CT and DT both signals can be classified as, here I have mentioned some of them: deterministic and non-deterministic signal, periodic and aperiodic signal, even and odd signal, energy and power signal. Now we are going to discuss everything one by one. So let us first start with deterministic and non-deterministic signal. Here, deterministic signal. Now what is deterministic signal? Those signal which can be completely specified in time. The pattern of this type of signal is regular and can be characterized mathematically. So here simply we can understand and remember this as deterministic signals are regular signals, as you can see over here. How this waveform is? This is regular. Look at this. This is regular. And this signal can completely be predictable. That is, no random variation will be there. You can look over here. Is there any random variation? No. This is continuous and deterministic. Okay. Now, what is non-deterministic signal? Non-deterministic signal simply we can remember as random signal. What are random signals? These are not uniform. You can see over here, these are not uniform. How are they? They are random in nature. See, random waveforms. So, this is also called as random signal or non-deterministic signal. Okay. They do not follow a fixed pattern and cannot be represented by a precise mathematical equation. Okay. So you understood about the deterministic and non-deterministic signal. Now we will see about periodic and aperiodic signal. What are the periodic signal? Periodic signal are, by the word itself, we can understand what is periodic. Periodic means on a regular interval period. Okay, it is called as periodic. A function that repeats its exact waveform pattern at interval of time, known as a period. Okay, defined mathematically by these signals are characterized by a defined frequency with common example including a sine wave, square wave, complex composite waveforms. Okay, and over here we can see also this waveform is in exact same. These are same waveforms. Okay. Now, non-periodic, by the name itself, you can understand non-periodic, how it will be. It will be like random. No regular intervals. Okay. So, a signal is a waveform that does not repeat itself regular, consistent interval over time. Okay. By the name itself, we can understand this. So, the non-periodic signal, you can see here, how are they? They are random in nature. Okay. Now we will study about even and odd signals. What are even and odd signals? Even signals is a symmetric signal that remains unchanged when it is inverted. For continuous, for discrete. It is a minor symmetry about the x-axis and y-axis, meaning the signal shape for negative time matches the shape for positive time. Means the signal is in perfect symmetry. You can see over here the even signals have perfect symmetry. Okay. And what are the odd signals? What are odd signals? Like in even signals, if we invert it, what will happen? We'll get the exact same image that we are getting on the upper side. Okay. But on the odd signal, if we invert it, will we get the same image? No. See, if we invert it, will we get the same image? No. This side will come over here and this side will come over here. So we are not going to get the exact same image. So these are called as the odd signal. It is a function that exhibits antisymmetry. Antisymmetry means if we invert it, we will not get the perfect symmetry. These signals are characterized by a value of 0 at the origin and commonly used in Fourier analysis to represent sine waves which are inherent odd. Okay. Now we'll study about energy and power signal. The energy signal is a signal with finite total energy and zero power, typically representing transient or non-periodic signal. That exponentially decaying function contains a finite amount of total work or information. Here you can see that this is a energy signal. Okay. Now, what is a power signal? A power signal is a signal with a finite non-zero average power. Here you can see this is a power signal. They typically represent sustained, non-decaying signals where energy continues to flow over an infinite time duration. Common examples include periodic signals, sine waves, square waves, etc. These are the power signals, as you can see, from minus infinity to infinity. In a particular time interval, you can see how these waveforms are represented. Okay. Now we are going to discuss about analog and digital signals. What is an analog signal? Analog signal is continuous, time varying, electrical, magnetic or physical, represents information by fluctuating in voltage, current or frequency. Okay, these signals are susceptible to noise and degradation over long distances. This is an analog signal. This is the amplitude and time. You can see these signals. These are the analog signals. Okay. And what is a digital signal? A digital signal is a type of signal that represent data using discrete typically in binary format, zeros and ones. You know how these are like a binary format, zeros and ones. Okay, ones, zeros, ones, zeros, like this. Okay, it is a digital form. Okay, unlike the analog signals, you can see here how the analog signals work. Unlike the analog signals that vary, the digital signal switch between specific voltage levels on and off. Okay, where zeros and ones comes, then we know that on and off. Okay, represents the information. These signals are used in digital communication, computing, and electronics because they are more resistant to noise, less prone to distortion, and easier to process than the analog signals. Okay, these are easy to process. Okay, thank you. I hope you all understood the classifications that I told you. In next lecture, we'll study about different types of system and their classification. So thank you. If any doubts, you can share. Okay. Thank you.